In this video, you'll learn how to simulate and calculate heating and cooling loads within the Ecotect environment. I'll briefly mention the necessary inputs, how to set up the model, and the process of simulating monthly heating and cooling load, where to locate and collect the data you'll need, and how to use it and analyze the design changes that you'll apply to your design project. I have now opened the Ecotect environment, and we're going to take a look at how we can simulate and calculate heating and cooling loads within Ecotect. First of all, it's necessary to understand the inputs that we have to set in. So first of all, we need to have validated geometry. That means that the directional arrows of the surfaces should point from the inside to the outside. It means that we should have calculated interzonal adjacencies, how many rays should spray out to calculate geometry, how far apart surfaces could be to be considered adjacent, etc. So when that's done, and of course we have made sure that we have set up the model with the right materials, and that we have marked out the model and say fixed length, mark these two down here and said okay, now the relation between the parent and the child object has been checked. So you see here that the surface area is the wall minus the window, and the exposed area is the whole wall. So this, okay, if you don't do this, you will have a lot of errors in your calculation. So the next thing we'll have to do, go to the analysis tab and go to the zone settings and go in and set up the internal design conditions to say, okay, how much clothes do people have on? Let's say business, relative humidity, exchange of air to the outside, how many lux how much light should be in the area, how many people. We can choose a guide, or we can type in the activity level. We could also make a schedule to simulate the behavior within the space or building more accurate. Sensible gains, lighting gains, and of course the infiltration rate and wind sensitivity, which is very important in here because Ecotect is using wind depending infiltration in the calculation of heating and cooling loads. So let's set this to 0.1, which is the demand in Denmark, and let's start out setting it to very sensitive. Okay, thermal properties, and choose what kind of system. So let's just choose none. And this means that really this type of system is really not if it's an air condition or whatever. It's just telling us that if we, for example, choosing an air condition, it will exchange the overheated and underheated periods to an effect in kilowatt or watt per hour. So if we choose full air condition, if the temperature drops because of cyclic variations, it will try to use energy. It will use energy to heat the building if it gets below 20 degrees, and to cool the building if it gets below 22. So these two can really be used as indicators for what we can manage within the space. Set up the hour separation and check that the total area, floor area, and volume are calculated correctly. So let's go to thermal properties again, just choosing none, okay, and just say calculate like that, and you'll see nothing happens. So let's see that because they weren't turned on as thermal, they won't be a part of the calculation. Let's try again, say recalculate, and now it's updating all the shading calculations and the interzonal adjacencies for the model, which is what takes some time when you're working with Ecotect. But when this is done, you can very fast try out different kind of materials based on orientation that you want to apply to your project to optimize and understand the relation. So what we can see now is that we have some periods where we need heating and some periods where we need cooling, and this is just coming out in kilowatt here. So what we can do now is we can use this graph to understand, okay, we have a cooling need. What can we do about it? And in the next video, I'm going to show how we can use the passive gains breakdown to identify where those cooling needs come from. If we want to take these data out, we can just right click here and we can generate a report taken to either Microsoft Excel or just CCS within Ecotect. So this will help us just that we don't have to set up all of these things when we get over to Excel or another program. So let's go back to the analysis tab, and let's change by orientation, by element type, the windows. Let's go in and change the windows to, let's say, another solar heat gain coefficient. Let's say 0.5, okay, 5 pins, say close, say store results here, and recalculate. So when we have really optimized the materials within the limits of the project, then we can begin to go in, for example, look at, okay, what is the most exposed windows to direct solar, and say, okay, what kind of shading do we need? And going in, using the shading design wizard to create some kind of understanding on the geometry. And if we want to simulate the thickness of the walls, we can just say select by element type, windows, and go to the transformation, choose extrude normal, and just say, let's say 500 millimeters thick, say apply changes, and then we kind of compensate for the window thickness within inside the model. And we can then go down and recalculate and see the impact of. Okay.